Deep inside industrial machinery, right now, something could be quietly tearing it apart. It's this hidden force that costs a fortune in repairs and downtime. It wears down components, it wastes energy. And today, we're going to go on an investigation to expose it. Let's get into it.
So, what are we talking about here? What is this invisible force of destruction? I mean, it operates in plain sight, but you often don't even notice it until it's way too late. This thing is the #1 cause of premature breakdowns, and yeah, it could be silently at work in your equipment as we speak.
And here you have it. The culprit we're hunting down today is misalignment. Yeah, I know, it might not sound super dramatic, but trust me, this is the silent saboteur behind a huge percentage of mechanical failures. It's such a small error, but it has absolutely massive consequences.
All right, Section 1, the unseen enemy. We're going to be understanding the fundamentals of proper alignment. So, to catch this saboteur, right, we have to understand how it operates. Proper alignment, it's really the bedrock of any healthy machine. Doesn't matter if its parts are connected directly with a coupling or indirectly with belts. Let's break down exactly what we mean.
Okay, so at its core, what is pump alignment? It's all about making sure the centerline of the motor shaft and the pump shaft are just perfectly matched. Think about it like two dancers. They have to be perfectly in sync, right? If they're not, the performance is clumsy, it's inefficient, and, someone's probably going to get hurt. Well, it's the same here. Proper alignment is what lets that power flow smoothly from the motor to the pump, no drama.
Okay, next up, couplings, a precision game. We're investigating the first method of attack. Our investigation is going to start with these coupled systems, where the motor and pump shafts are connected directly. In this kind of setup, it is absolutely a game of precision. Any tiny bit of misalignment is going to cause direct and pretty severe damage.
So this misalignment, it really shows up in two main ways. First, you've got what's called parallel or offset misalignment. Just imagine two perfectly level highways that just don't quite line up. Then, you've got angular misalignment. This is where the two shafts meet at an angle instead of forming a perfect straight line. And you can bet both of these create some intense stress on all the components.
And this right here, this is the crucial point. It doesn't take much. The source material is super clear on this. Even a minor error puts immense stress on the whole system. And that stress, it creates vibration. And vibration? Well, it's the mortal enemy of any machine. It's basically a one-way ticket to the premature failure of your bearings and your seals.
So how do you even check for this stuff? Well, the old school way was just using a simple straight edge. I mean, it's quick, but let's be honest, it's really just a good guess. In the modern world, the real tool, the professional tool, is laser alignment. It's just incredibly precise. It uses sensors and software to get that alignment absolutely perfect, right down to the manufacturer's exact specs. It really is the difference between just eyeballing it and using a sniper scope.
All right, let's move on. Belts, tension, and truth. We're going to examine a different kind of connection. So now let's investigate our second scene of the crime, belt drives. Here, the shafts are parallel, sure, but they're connected by belts. And this setup, it's great because it allows for different operating speeds, but it brings its own unique set of alignment challenges to the table.
With belt drives, our little saboteur has two main tactics it likes to use. First up is sheave alignment. The sheaves, those are the grooved wheels the belts sit in, they have to be on the exact same plane. If they're not, that belt is going to wear out incredibly fast. Second, and this is just as critical, is belt tension. This is something that needs constant attention.
And this is so important to get. Belt tension really is a delicate balancing act. It's not just about making sure the belt is tight enough. You can get this wrong in two totally different, but believe me, equally destructive ways.
And you can see the two failure modes really clearly here. If the tension is too loose, what happens? The belt slips. That generates a ton of heat and it wears out super fast. But what if the tension is too tight? Well, that's actually even worse. It creates what's called an extreme radial load, which is basically a death sentence for the machine's bearings.
So what exactly is this radial load thing? Well, think of it like this. Bearings are built to handle the forces inside the pump, right? When you go and over-tighten a belt, you're adding this powerful, external pulling force that the bearings were just never designed to handle. It's this immense stress that literally pulls them apart, and that leads to, you guessed it, catastrophic failure.
So it doesn't matter if it's from a misaligned coupling or an improperly tensioned belt.
The consequences are always severe. This whole idea of alignment being close enough, it's a complete myth. Let's start tallying up the real-world damage caused by our silent saboteur.
Okay, so here are the top 3 victims in all of this. First, bearings. They get absolutely shattered by the constant vibration and all those unnatural loads. Second, the mechanical seals. They are super sensitive and they just get destroyed as the shaft wobbles and vibrates. And third, you are literally just throwing money down the drain on wasted energy because the motor is fighting against all that unnecessary friction and stress.
Yeah, this chart makes it crystal clear, doesn't it? By far, and I mean by far, the most frequent casualty of misalignment is bearing failure. It is the #1 symptom and the #1 point of failure. So if you find your bearings are failing over and over again, misalignment is almost certainly the culprit you should be investigating first.
Okay, but here is the good news. This saboteur, it's actually pretty easy to stop. You just have to be precise. Investing a little bit of time in using the right tools for proper alignment, it doesn't just prevent disaster, it pays you back with huge dividends.
And here are those rewards. I mean, check this out. You get longer equipment life because you're not needlessly destroying your own stuff. You get lower energy bills because the machine is running efficiently the way it was designed to. You get way greater reliability and less of that unexpected painful downtime. And hey, as a bonus, the whole operation is quieter and smoother. It's a win on every single level.
So, we're going to end with this question. Is good enough alignment silently sabotaging your bottom line? I mean, after seeing all this evidence, it's pretty clear that good enough is really just another way of saying failing slowly. The crucial takeaway here is that precision isn't some kind of luxury. It is a fundamental requirement for any healthy, efficient, and, profitable operation. The real question isn't about the cost of precision. It's about the staggering cost of ignoring it.